Last time we were looking at this section, we got to the propeller governor and kind of talking about how it works, right? And so just a quick review of that. The propeller governor ultimately is going to control the blade angle, and it does that by, I guess I should ask you, how does it control the blade angle? What is it controlling? Does anyone know? What does it do to alter the blade angle? What do we use to alter the blade angle? Oil pressure. Okay, we use oil. It's a hydraulic action to move the blades. Okay? And so this propeller governor is going to either port or not port. Some of them change the blade angle. Some of them go to a higher blade angle by porting oil to the propeller. Some propeller and governors do it the opposite. Okay, depends on manufacturer and design of the specific propeller. But in any case, what happens is, so in a steady state situation, to review that, which is what's here, okay, let's have a steady state position. This is the power lever is in a certain position, the condition lever or the propeller lever, excuse me, here's my turboprop side coming out. The power lever or the throttle's in a certain position, the mixture's in a certain position, the propeller lever's in a certain position. We're not moving any of them, okay? There are going to be factors that can cause the propeller speed to change. What kind of factors might cause the propeller speed to change? What would cause the propeller to speed up, possibly? Why would it speed up? If we don't touch any of the levers, what can cause that propeller to speed up? What? A gust of wind. From which direction? Towards the front of the aircraft. Right? That's going to make it easier. It's trying to move air back, right? It's trying to move air from here back here. So if there's already a gust of wind, it's going to make it easier. That's going to allow it to spin faster at a given power setting. Okay, so a gust of wind. What else could cause that propeller to speed up? There's other controls that your pitch, right? The pitch of the aircraft. If, say, the aircraft pitches down a little bit, right, that's going to accelerate. Okay. It's also going to change that relative wind angle. It's going to make it easier for the propeller to spin. It's going to speed up. So what's going to happen? The propeller governor is going to sense that increase in RPM. And what's it going to do? It's going to try to take a bigger bite of the air. It's going to increase the blade angle, increase the angle of attack to a point where the propeller gets back to the speed that we've selected with the propeller lever. Okay, we basically are asked, we're like, prop governor, please give me 2,200 RPM, right? That's kind of what we're asking when we move the prop lever. Like, this is the speed I want, please give it to me. The flip side to that is what's going to slow it down? What could slow down the prop speed? Again, not moving any levers, so the opposite. Tailwind, what did you say? Or we pitch the airplane up, okay? Bird strike, that's a little different story. Hopefully not. But so now that's going to cause the prop to slow down. So what do we do with the blade angle? If we slow it down, what do we have to do to get it to speed back up? Do we increase or decrease the blade angle? Decrease the blade angle. That reduces the amount of air being pulled by the prop. It helps to speed it back up. But the engine speeds back up, puts more power into it. You know, the engine, the throttle is trying to maintain a certain RPM as well of the engine, right? Prop governors maintain the RPM of the propeller. The throttles maintain the RPM of the engine. They work together. Okay. The other side of that is, what if I make the changes? So instead of there being a gust, let's say now the airplane's in a steady state. It's flying flat and level. There's no wind from the front, no wind from the back, no wind from the nose, no wind from the tail. Okay. I push that propeller lever forward. What does pushing the propeller lever forward try to do? What am I telling the propeller when I push that lever forward? What am I telling the governor I want the propeller to do? If I push forward, what does pushing a lever or a knob forward do in an airplane? It increases whatever it is. It increases the throttle, or in this case, it increases the RPM I want. Okay? So now I've pushed it forward. I'm telling the governor I want more RPM. And it's looking at what the propeller is actually at, and it's saying, oh, wait a minute, now the RPM's not high enough. So what's it going to do? What do I have to do to increase for that propeller to increase RPM to match what I'm requesting with the lever? It's going to bring the blade angle to a lower angle. It's going to decrease the angle of attack. It's going to take a smaller bite of air. There'll be less resistance, and the propeller will begin to spin faster. Okay. If I take that prop lever and I pull back on it, what's that going to do? What am I telling the governor at that point? We want less RPM. And so the flip side, the opposite's going to happen. It's going to increase blade angle, increase the amount of resistance on the propeller because it's taking a bigger bite of air, and the propeller RPM is going to drop. Okay, that's in what's known as the governed range. Okay, that's the range where there's enough power being delivered to the propeller that I can alter it. I can increase the pitch, decrease the pitch in order to keep the RPM the same. What happens if I reduce the engine power to a point where I can't even maintain minimum RPM? So the prop governor, what's it going to do to try to keep that RPM up? I've pulled back on the power lever, the RPM starts to drop. What's it going to do to try to keep that RPM where I've asked it to be? It's going to bring blade angle down. It's going to go to a finer pitch. But there's a physical limit to how far it can drive the blade angle. Okay, once I'm at my minimum pitch, if I still don't have enough power, that propeller is going to start to slow down. Now we're out of what's known as the governed range. We're in the ungoverned range, and it acts like what type of a propeller then at that point? It basically becomes a fixed pitch propeller. So if you're below the governed range, if you're below the range where there's enough power to be able to increase the blade angle's now locked at its minimum pitch. You add power, the propeller is going to speed up. You reduce engine power, throttle, it's going to slow down until you get to that governed range. And then if you increase or decrease power in the governed range, then the prop governor is going to try to maintain a set RPM. Okay? So that's the bottom there. Okay, when the engine does not have enough power to achieve the governed RPM, the blade angle is held at its lowest flight blade angle, the lowest pitch. And now it acts like a fixed pitch propeller, a very fine pitch, fixed pitch propeller. Mention that it's hydraulic in action. It uses oil in order to do this. So here on our engine, you can see, and I'm going to have governor accumulator right now, because not all of them even have that. Okay. We're going to ignore the accumulator. We're just going to look at, you can see engine oil. There's a pressure port in red there, going into the governor. Okay. There's the oil drain. There's a blue return to send oil back to the engine. So we're going to use our engine oil. That's our hydraulic fluid, is the same oil that's being used to lubricate the engine. And then there's a third part, the dark red coming out of there, that goes up to the propeller itself. And it goes through ports typically in the crankshaft. And when you've looked at crankshafts, you see there's a big hole right in the end of them, right in the center of the flange. That's the oil passage to allow oil to flow from the engine up into the propeller, okay, the constant speed propeller. And then the propeller has this dome at the front, which is basically what? What is that dome housing? It might have an air charge, but for a hydraulic thing, what is it essentially? If we're going to port oil to or from it, becomes what? Becomes what? A cylinder, an actuator, right? A hydraulic actuator in there. Now it can have an air charge as well, and it's probably going to have a spring. Okay, a lot of them have springs, some of them have air charge. We'll look at that in a minute. But there has to be, the oil is going to push it one way, the spring or air charge or even centrifugal weights is going to push it the other way. Anyone know what kind of a hydraulic actuator that is? It's kind of a review of basic systems. If the hydraulic pressure moves an actuator or a piston one direction only, and then it uses something else to move it the other way, anyone know what that's called? You remember single acting hydraulic cylinder? A single acting actuator? Uh-oh. We'll have some review to do next year when you have me for advanced systems. Okay, you can have single acting or double acting actuators. So oil is pushing it one direction. It uses something else to move it the other direction. That's called a single acting. So it's a single acting hydraulic. It's a single acting hydraulic actuator that is going to move the blades. That is going to control that blade angle. Okay. Here is a cutaway of what that looks like. So in this instance, in this version, I've got two versions of these. You have, I'm going to make sure my signal's good, which it looks like it is. Okay. In this version, which it is a little bit hard, this is a Lycoming engine with the starter ring gear. So they show the ring gear. You got the shaft. Here's the propeller shaft right here, the crankshaft, and it's hollow. So oil can port up the middle of it. Okay. And in this case, the oil is able to port up a tube through the propeller to the very front of the dome. Okay, here's the dome. This is just your prop spinner here. But the actual dome is right here. Okay. So in here, this piece, the piston, is able to slide forward to the right or to the left. Okay. And as it does that, it's connected to the blades in such a way that it will rotate or it'll adjust the angle, the blade angle of the blades. Okay. And so in this case, what you have is oil pressure goes in front and is going to push the piston to the left. There's a spring in here, a big spring, that pushes the piston back to the right. Okay. And then that's connected, this pitch change rod comes back and keys into forks on the blade in order to make that change. Okay. You can also have the opposite. So in this case now, you can see the oil is ported to the back of the dome, behind the piston, to the left. And here we actually have a spring and an air charge. An air charge basically is just a spring. It's an air spring. And so those work together to push the piston back to the left in this case. And same thing, they are going to move the blades. And then you've got your counterweights here. So what happens with these, for this one for instance, these counterweights are also acting on this. Their centrifugal force is going to want them to line up with the center line of the blades as much as possible. They don't want to be sticking out in front when it's spinning. They want to be lined up. It's kind of like, how many of you, I know they took these out of most playgrounds nowadays, but merry-go-rounds, you run around, right? What happens when you lean out? It pulls you really hard, right? What happens when you lean in? It spins faster, and it's also less force on your body, right? So those weights are going to want to go to the center. They want to rotate so that they're in line with the plane of rotation, okay, and to help move the blade back the other way. So in this case, oil pressure will reduce the blade angle and increase the RPM. Okay. If you reduce the oil pressure, this air spring and piston are going to go the other way. That's going to increase RPM. Okay. So if does it say on this one? I can't remember which one this one. There we go. This earlier one, so here the cylinder, oil pressure increases blade angle, reduces RPM. Okay, so with this first blade here, if our propeller is spinning too fast, our prop governor is going to send oil to the front of this dome. Okay, and that's going to increase the blade angle, and it's going to slow it down. So in this instance, with this design, oil pressure drives it to a higher blade angle. The flip side is in this design, oil pressure, the governor basically is just plumbed kind of the opposite way. So now if the prop is spinning too fast, it cuts off the supply of oil, it reduces the supply of oil, and then the air pressure and spring are going to push it to that reduced RPM in order to, that reduced blade angle in order to increase RPM. And so these can work either way. And it's in the design of the governor, how it, which way it ports. You have to have a matched, the governor and the prop are matched together, whether they're a pressure to increase blade angle or a pressure to reduce blade angle, or the opposite, pressure to reduce blade angle, decrease pressure to increase blade angle. Here is a very simple version of the propeller governor. Okay? And you can see it has an integral oil pump. We need a fair amount of pressure to do this. Oftentimes the pressure used by these is higher than the engine operating pressure. So they take engine oil, but then in this case it has its own oil pump there. It has a gear style oil pump to boost that pressure even higher. And then what you have, so the oil comes in and it gets pumped by our pump. Okay. And then it comes out through this port right here. And ultimately, you can see it flows out here on the right, or sorry, on the left. Depends on which way you look at it. Looking at it to the left, propeller. And so what'll happen is these fly weights, as these fly weights are going to push out. They're going to move away from each other. And as they move away from each other, they compress this spring right here, and they lift this valve up. Okay, they lift this pilot valve up. And when they lift this up, this kind of barbell area, the skinny area, will connect this pressure port here to the propeller line. Okay. So when they do that, so we increase speed in this version. Increasing speed opens our pilot valve. That sends pressure to the propeller line. Okay, if our speed is increasing when we don't want it to, what is it going to do? What are we trying to do? So speed is increasing when maybe we don't want it to. What do we have to do? If the speed is increased, so now it's faster than what it should be, what do we do to blade angle? We increase it. So this, when it goes faster, these fly weights move out. They push up on this pilot valve. That allows oil to flow out to the prop. So what is the oil doing on this propeller? Is oil increasing pitch, no pressure increasing pitch, or is it going to reduce the pitch? This is going to increase the pitch. Okay, the design that's here, because those springs, or sorry, those fly weights activate the pilot valve to allow pressure to flow when the speed increases. This uses pressure to decrease the speed. We decrease the speed by increasing the blade angle. To make it a little bit more complicated, we add a little bit on. So here's our same fly weights going to the pilot valve. Now, the opposite can be true as well, I should say. If this was lower, when the weights come in, this drops down, we can make it work the opposite direction. Okay, so this one just happens to increase blade angle as the speed increases, which is to slow the plane down. It sends pressure out. The other way is you can build this so that as the speed increases, it cuts off pressure. Okay, in order to increase blade angle. That's if you have air charger spring that increases blade angle. In this case, the air charger spring decreases blade angle. The hydraulic pressure will increase the blade angle. To be able to control this one here just has a fixed speed spring. Okay, this would be a fixed one. There's no adjustment here. To control this, most of these then, this little module on the top, and this is where the propeller lever attaches. And so we can increase or decrease the prop speed by adjusting how much tension or how much compression is put on the speed spring that counteracts these fly weights wanting to swing out. Okay. The fly weights are L-shaped. You can see as the speed increases, they're going to swing out like this, and that causes this toe to push up on this kind of, you'd probably call it a squash plate. Okay, they don't have a name for it on here. But if you put more if you push down on this spring, you put more pressure on it, that's going to resist these flyweights being able to, being able to spread out, right? If you put less pressure on it, the flyweights are going to be spread out more. And so that's how we control, how we tell the prop governor, I want more or less, RPM on my prop. Is I allow the flyweights to spring out easier or spring out less easy. And that's going to be opposite again, depending on whether it's designed to port fluid in order to speed the propeller up, or it's designed to cut off fluid to speed it up. The action of the speeder springs and the adjustment is going to be reversed depending on the design of, the prop governor and the prop and which way oil drives it. So that's this lever up here is what's attached to the speed adjusting control lever is what's attached to our prop lever in the cockpit. And as you turn that, this piece right here, this lift rod, can either be pulled up or pulled down in order to increase or decrease the tension on the speeder spring. Essentially, we have this adjusting worm gear. As this turns, this whole thing can kind of screw down, where this right here will drop down, or it will go up in order to increase or decrease the amount of force being put on the top of that spring. So here's an example in the two different positions. So on the left, we've put tension on the spring, which is pushing the toes of the flyweights down. So it would take a higher RPM in order to get them to swing out and move that pilot valve. In the right, we've reduced the tension on the speed spring. The flyweights are able to swing out easier, and there's going to be less resistance to pulling that pilot valve up. And again, depending on the design, they could work either way, whether it's for a oil to go fine or an oil to go coarse. There's just kind of an opposite, it works in an opposite manner, but they accomplish the same goal, okay? So there's a couple manufacturers of props out there. Actually, let's see.